Hi, I'm Chris Friedemann, Chief Marketing Officer for NEOS GeoSolutions. Natural resource exploration teams are growing increasingly excited about creating a better view of the subsurface by integrating multiple geological and geophysical measurements simultaneously. NEOS is poised to be the leader in the emerging area of multi-measurement subsurface interpretation. We have developed the field acquisition technologies, built the data integration and interpretation platform, and assembled the geoscience team to help our clients make faster, more informed decisions about where to explore, where to lease, and where to drill. NEOS believes that an integrated geostatistical analysis of multiple G&G data sources, including data available in the public domain, owned by our clients, or acquired using our proprietary platforms, leads to more accurate 3D models of the subsurface. We firmly believe that seismic will remain one of the most important tools in the explorationist toolkit. However, there are limitations to the method, especially onshore. For one thing, seismic requires equipment to be placed directly on the surface, which can be difficult in topographically challenged or environmentally sensitive areas, or regions affected by political or military conflict. Seismic projects also require support from large staking, layout, acquisition, and maintenance crews, which themselves require additional logistical services. While NEOS believes that seismic will remain a core tool for hydrocarbon exploration, we also believe that a multi-measurement approach that integrates all G&G information can deliver improved subsurface insights. Since these additional measurements can be acquired using airborne sensor systems, they overcome many of the drawbacks that adversely affect the seismic method. Jim Hollis, NEOS's President and Chief Executive Officer, explains why more measurements can improve exploration success.
The best analogies around multi-method geophysical exploration is what goes on in a doctor's office. You have some sort of problem in your body, a doctor has the tools such as X-ray, MRI, blood test, stress test. All of these are fused to get a holistic understanding of what's going on and what might be wrong within your body. We're applying that same idea in exploring in the subsurface for minerals and hydrocarbons. We're taking multiple different methodologies, geophysical techniques that each measure something different about what's going on, and then geostatistically fusing them into a single answer. That's what gives you the insight, that's what reduces the uncertainty, and that's what drives finding costs down.
The multi-measurement approach has been used by the minerals industry for some time, primarily because seismic has been viewed as a high-cost method. In addition, several non-seismic measurements, including radiometric or magnetic surveys, are especially relevant to mining, as they can be used as direct detectors for minerals like uranium or for ores like iron or nickel. Jim explains how both the mining and E&P industries can make use of multiple G&G measurements.
One of the projects we recently worked on was looking for fracture systems in the Colorado Rocky Mountains. In this area, we fused all of the information we got from the hyperspectral at the surface that allowed us to identify the fractures there at the surface, all the way to the depth where magnetic data, gravity data, electromagnetic data all helped us understand not only where the density of the fracture was, but as well as the orientation, which allows us to identify sweet spots and pick better drilling locations.
One of the key data streams acquired during a NEOS survey involves recording hyperspectral data across more than 600 contiguous channels, from ultraviolet to thermal infrared. Hyperspectral sensors measure the reflectivity and emissivity of materials on the Earth's surface, which once interpreted provides a detailed spectral fingerprint of hundreds of surface-based indicators known to be associated with underground deposits of ores, minerals, and hydrocarbons. Jim tells us a bit more about how NEOS makes use of hyperspectral data.
One really good example is using hyperspectral to look for gold. We can use the hyperspectral fingerprints to identify clays at the surface that are associated with the placement of the gold ore body through the hydrothermal systems. This allows us to remotely gather geochemical signatures across vast areas and focus in on where the sweet spots are, where the gold is most likely to be.
NEOS's client partners include energy ministries and national oil companies, E&P and mining firms, and governmental agencies. Our varied client base requires us to offer a diverse set of solutions to the business problems they face. In the interest of time, let's focus on our two most popular offerings and turn once again to Jim to describe how they are used.
Our NEO Basin solution involves integrating multi-measurement data from third-party satellite providers and NEOS-operated aircraft over broad areas, generally 1,000 square kilometers or more. Our clients work with resulting interpretation in a variety of ways, but the most common uses are to hydrate existing acreage and to prioritize upcoming lease bids and claim stakes within a targeted area of interest. We combine satellite data with gravity, magnetic, and hyperspectral data, along with publicly available or client-supplied GMG datasets, maps, and reports to feed our simultaneous multivariable inversion. We generally put these NEO Basin surveys together on a multi-client basis, with projects starting to come together in California, the Rockies, Western Canada, and South America. Our second most popular solution is something we call NEO Prospector. On a NEO Prospector survey, we're looking to help our clients identify potential drillable prospects based upon a variety of GMG measurements that correlate with known producing fields or mines within the area of interest. While our multi-measurement inversion technique can be applied in the absence of any controlled data sets, our technique is inherently more accurate and predictive when the types of measurements to be used and the geostatistical correlations among them can be tuned using a known discovery. In a NEO Prospector survey, we fly our aircraft in a tightly gridded pattern to obtain the highest resolution data possible. In most of the NEO Prospector projects I've been involved with, the interpretation is exclusive to the client that commissioned the survey.
A side benefit of most NEOS surveys is our ability to deliver an environmental baseline resulting from analysis of our hyperspectral data. We can process hyperspectral data and deliver an environmental baseline that highlights the condition of the surface when our first survey is acquired, and if desired, be compared to future time-lapse surveys. In one example of baselining, we are using hyperspectral technology to monitor the health of vegetation in Gulf Coast wetlands impacted by the Macondo oil spill. Our analysis guides remediation teams to areas that are most likely to respond favorably to intervention and lets interested parties monitor the effectiveness of regional restoration efforts. NEOS was formed as a different kind of geosciences company where Silicon Valley meets the oil patch. One of our largest investors is the venture capital firm Kleiner Perkins Caulfield & Byers, the entity that backed pioneering companies such as Google. By tapping into the networks of Kleiner Perkins and our other lead investors, we ensure our methods incorporate the latest thinking in sensors, computing, neural networks, and intelligent search.
NEOS believes that we are at the dawn of a new era of geoscience. While modern explorations can access a large portfolio of technologies to guide their efforts, no one company has focused on bringing all of these information sources together on a single interpretation platform until now. NEOS has the capabilities to usher in this new age of modern exploration and to help our clients make sense of the data already at their disposal and optimize their decisions about where to explore, where to lease, and where to drill.
Thanks so much for spending the time with us today to learn a little bit more about our company and our technologies.